Welcome to the lesson on sound. Of the lesson, you will be able to explain production, propagation, and characteristics of sound. Explain reflection of sound and its uses. Explain applications of ultrasound. Know about structure of human ear.
Oh my God! This sound is disturbing. I can't study in such a noise.
But do you know how this sound is produced?
Not exactly.
This sound can be produced by many ways, like striking the tuning fork, by plucking a guitar string, scratching a rough surface, rubbing, blowing, or shaking objects. Actually, to produce sound, we set the objects vibrating.
But Dad, how the sound of human voice is produced?
It is produced due to vibrations in the vocal cord. We can understand this with some examples. When a vibrating tuning fork is touched to a suspended table tennis ball to deflect.
Dad, how does sound propagate?
Sound propagates through mediums like solid, liquids, and gases. When object vibrates, it sets particles of mediums around it vibrating. A particle of medium in contact with vibrating object is first displaced from its position and then exerts force on the adjacent particle. As a result, the adjacent particle gets displaced from its position of rest, and then first particle comes back to its original position. This process continues till sound reaches its destination.
That means disturbance travels through the medium. Particles do not travel.
Yes, a wave is a disturbance that moves through a medium when particles of medium set neighboring particles into motion. Hence, sound can be visualized as a wave called mechanical wave.
How does sound travel in air, Dad?
When vibrating objects move forward, they push and compress the air, creating a region of high pressure, followed by a region of low pressure, known as compression and rarefaction respectively. Compression is denoted by C and rarefaction is denoted by R. This pressure is related to a number of particles in a given volume. More the density of particles, more is the pressure and vice versa. Propagation of sound can be visualized as propagation of density variations in medium. Sound needs mediums like air and water for its propagation. It cannot travel through vacuum.
Dad, are sound waves longitudinal or transverse?
As you know, in sound waves, the particles do not move from one place to another, but they oscillate back and forth about their position. Also, these waves move in a direction parallel to direction of propagation of disturbance. Hence, sound waves are longitudinal waves.
What are the characteristics of a sound wave?
The main characteristics of sound are crest and trough of a wave, wavelength, frequency, time period, pitch, amplitude, quality, speed, and intensity of sound.
Please explain this to me in detail, Dad.
As you know, compression is the region of high pressure and high density. The region is shown as peak in wavelength. Rarefaction is the region of low pressure and low density. This region is shown as valley in wavelength. This peak is called as crest and valley is called as trough of wave. The distance between two consecutive compressions or two consecutive rarefactions is called the wavelength. The wavelength usually is represented by Greek letter lambda. Its SI unit is meter. The change in density from the maximum value to minimum value, again to the maximum value, makes one complete oscillation. The number of such oscillations per unit time is the frequency of the sound wave. It is usually represented by Greek letter nu. Its SI unit is hertz. The time taken for one complete oscillation in the density of the medium is called the time period of the sound wave. It is represented by symbol T. Its SI unit is second. There exists a relation between frequency and time period. Frequency is equal to 1 upon time. Can you hear that, Ankur? Can you hear the sound of different instruments? Though sounds from different instruments travel at the same speed in the same medium, the sounds we receive are different. This is due to difference in pitch of the sound. Pitch is directly proportional to frequency. Objects of different sizes and conditions vibrate at different frequencies to produce sound of different pitch. The magnitude of the maximum disturbance in the medium on either side of mean value is called the amplitude of wave. It is usually represented by the letter A. For sound, its unit will be that of density or pressure. If we strike this table lightly, we hear a soft sound because we produce a sound wave of less energy. If we hit the table hard, we hear a loud sound. The loudness or softness of a sound is determined basically by its amplitude. The amplitude of the sound wave depends upon the force with which an object is made to vibrate. The quality or timbre of sound is that characteristic which enables us to distinguish one sound from another, having same pitch and loudness. The sound which is more pleasant is said to be of a rich quality. A sound of single frequency is called a tone. A sound which is produced due to a mixture of several frequencies is called a note and is pleasant to listen to. Noise is unpleasant to the ear. Music is pleasant to hear and is of rich quality. Sound energy passing each second through unit area is called the intensity of sound. We sometimes use the term loudness for intensity, but they are not the same. Loudness is a measure of the response of the ear to the sound. Speed of sound is the distance which a point on wave, such as compression or rarefaction, travels per unit time. Numerically, speed is given as distance upon time. Hence, V is equal to lambda upon T. Since nu is equal to 1 upon T, hence V is equal to lambda into nu.
Dad, the speed of sound remains same for different medium?
No, the speed of sound depends on properties of mediums through which it travels. It depends on temperature of the medium. Speed of sound increases with increase in temperature. For example, the speed of sound in air is 331 m upon s at 0 degrees centigrade and 344 m upon s at 22 degrees centigrade. The speed of sound decreases when we go from solid to gaseous state.
Dad, why does the sound of a thunder lightning is heard a little later than the flash of light is seen?
Since speed of sound is less than speed of light, That is why you hear a thunder later than the flash of light is seen.
Sound also show property of reflection, same as light?
Yes, it does show. The directions in which sound is incident and is reflected make equal angles with normal to the reflecting surface at the point of incidence, and the three are in the same plane.
Dad, I heard about echo and reverberation. Are they same?
No, they are quite different. If we shout near a suitable reflecting object, we hear the same sound again after some time. This sound which we hear is called an echo. The sensation of sound persists in our brain for about 0.1 second. To hear a distinct echo, the time interval between the original sound and the reflected one must be at least 0.1 second. Echoes may be heard more than once due to successive reflections. The roaring of thunder is due to successive reflections of the sound from a number of reflecting surfaces, such as the clouds and the land.
And what about reverberation?
A sound created in a big hall will persist by repeated reflection from walls. The repeated reflection that results in this persistence of sound is called reverberation.
The uses of multiple reflection of sound, Dad?
Megaphones, horns, and musical instruments like trumpets use the principle of multiple reflections. In these instruments, a tube followed by a conical opening reflects sound to guide most of the sound waves from the source in the forward direction towards the audience. In a stethoscope, the sound of the patient's heartbeat reaches the doctor's ears by multiple reflection of sound. In a concert and a cinema hall, the ceilings are curved, and also curved soundboards are placed behind the stage, so that sound after reflection spreads evenly across width of the hall.
The audible range of sound for human beings?
Well, it extends from 20 Hz to 20,000 Hz. Small children and animals like dogs can hear up to 25,000 Hz. Sounds of frequencies below 20 Hz are called infrasonic sound or infrasound. Since earthquakes produce low-frequency infrasound before the main shock waves begin, some animals who can hear infrasound get disturbed. Frequencies higher than 20 kHz are called ultrasonic sound or ultrasound. Ultrasound is produced by dolphins and bats. Sounds are used to clean industrial machine parts in which dirt is located in hard-to-reach places. Due to high frequency, the particles of dust, grease, and dirt get detached and drop out. The objects thus get thoroughly cleaned. Ultrasounds can be used to detect cracks and flaws in metal blocks. If there is even a small defect, the ultrasound gets reflected back, indicating presence of defect. They are used in a technique called echocardiograph, in which image of the heart is formed using these waves. Ultrasound scanner is an instrument which uses ultrasonic waves for getting images of internal organs of the human body. They are widely employed to break small stones formed in the kidney into fine grains.
Dad, how does sonar system work using ultrasonic waves?
Sonar stands for Sound Navigation and Ranging. Sonar is a device that uses ultrasonic waves to measure the distance, direction, and speed of underwater objects. It consists of transmitter and detector. Transmitter produces and transmits ultrasonic waves. These waves, when reflected back, are reused by the detector. The detector converts the ultrasonic waves into electrical signals, which are appropriately interpreted. The distance of the object that reflected the sound wave can be calculated by knowing the speed of sound in water and the time interval between transmission and reception of the ultrasound. Let the time interval between transmission and reception of ultrasound be T, and the speed of sound through seawater be V. Then total distance 2D travelled by the ultrasound is equal to V into T. This method is called echo ranging. Now, let us learn about the structure of the human ear.
Yes, Dad.
The ear allows us to convert pressure variations in air with audible frequencies into electrical signals that travel to the brain via auditory nerve. The outer ear is called pinna. It collects sound and then this sound passes through the auditory canal. At the end of the auditory canal, there is a thin membrane called the eardrum or tympanic membrane. During compression, eardrum moves inward, while during rarefaction it moves outward. This is how eardrum vibrates. Vibrations are amplified in middle ear and then transmitted to inner ear. In the inner ear, the pressure variations are turned into electrical signals by the cochlea. These electrical signals are sent to the brain via auditory nerves, and the brain interprets them as sound.